I'm curious, everyone's here for the part one of the Fast.ai course. I see a couple of people who were on previous, who did the last go around with us. I'm curious, are folks just getting started with the course? Does anyone want to chime in and kind of share what they've been up to with the course and with deep learning in general?
Hi, Sam. My name is Adrian. I dipped in for a couple of the study groups at the last go-around, but I didn't have time to attend all, so I'm hoping to make more of a commitment to this one. Yeah, my background is predominantly software engineering. I've been moving into machine learning and data science over the past couple of years. So PyTorch is the language I've been using for the past year, where I've been trying to write models based on existing papers such as Linnet, ResNet, and others. But I'm just looking for a deeper intuition of deep learning, and from the meetups that I attended over the summer months, just a couple, just from the discussions and the talks ongoing during the meetup, I gained a lot of intuition, and it was good just to talk about these concepts. So I'm hoping for more of the same, really. So
awesome. Yeah, one of the things that
thanks for doing this. Yeah.
Sorry, go ahead.
Sorry to cut into there, Sam. No, I appreciate you taking the time doing this again. So, or if it's Sebastian that's taking over after this, but yeah, it's great that this is available.
Absolutely. I think everyone who did it last time that stuck through it really got a lot out of the class. Last time we started, the intention was to do a weekly pace, which worked okay for the first few lessons. But then by the time we got to lesson 4, it really became difficult for folks to get through everything. So one of the things that Sebastian wanted to do differently this time around was to start with the very beginning of an expectation of taking a couple of weeks to go through each of the lessons. And so that should put this section of the study group finishing up around mid-December, just before the holidays. Anyone else like to jump in and kind of share your background, what you're hoping to get out of the study group, any experience you've had with the Fast.ai course?
Can you hear me, Sam? I'm Tony.
Hi, Tony. Yep.
Oh, I have not prepared at all for this Fast.ai course, but I did go through Andrew Ng's deep learning specialization with Coursera. I liked the content quite a bit, but the TensorFlow part of it, I don't know, I'm hoping that I like PyTorch better than TensorFlow. That's one reason I'm interested in this course. And I'm wondering a little bit about so what will happen? So can you say a little bit in general about the 2 weeks or so, for example, in between our meetings? What will we be doing then? We would be watching the course video and working through a notebook on some NVIDIA GPU that we have access to, basically.
So good question in there. My assumption from the conversation with Sebastian is that this study group would meet weekly and every week talk about kind of roughly half of the videos from a given week of the Fast.ai course. And maybe I should take a step back and kind of review the structure of the course. The course is formally called Fast.ai Deep Learning for Coders. And this is the part 1 course. The course is organized into 7 videos or 7 lessons. Each of the lessons, the video runs around a couple of hours long, if I remember correctly, and oftentimes the structure is, or at least towards the end of the the class, what ends up happening is the videos are recordings of a live session of this Fast.ai course that's delivered in San Francisco. And what will happen is for the first half of this couple-hour video, Jeremy Howard, who's leading the course, will kind of review the previous week and talk about, answer questions that are brought up by the audience, as well as people that submit questions via email. And I think they're taking questions via Twitter or something else, forums. But he's addressing questions and going into additional detail about the previous week's lesson. And then he is, the next half of that video will be kind of new material for the week. The course itself, unlike courses like if you've ever taken one of Andrew Ng's courses, the Deep Learning.ai course or his original Stanford machine learning courses, unlike those, which are bottom-up courses, meaning you're learning about kind of the math that governs training, and then you're doing exercises to reinforce that math. This course is a top-down course, which means he's starting from a problem. The initial lectures are focused on computer vision, so object detection, things like that. So you're starting with that problem, and he basically provides a notebook that has how to solve that problem, and you're, over the first few weeks, incrementally going deeper and deeper into how to solve that problem. And with each of the lessons, you're gaining greater understanding about how to solve that problem. And what's pretty cool about the course is that almost right off the bat, without getting bogged down in a lot of mathematical notation, you learn how to repeatedly build a world-class object detector, and you'll try it against data sets that you can find on Kaggle and other places. And then later on, as the course gets deeper into the materials, at the beginning, you're building your training models and building these object detectors and stuff with kind of high-level APIs. And then later in the course, you're basically writing this stuff from scratch. So that's why they call it top-down. In the last session, we spent quite a bit of time actually talking about this top-down approach versus the bottom-up approach, because I think for most of us that took it last time, it was a new way of thinking about learning something, and in a lot of ways, very uncomfortable. You know, everyone who's here is here because you're used to learning things independently, and you kind of start by digging in and learning the foundations and kind of working your way up. And with this approach, you kind of, there's a certain amount of faith that's required. You have to kind of dive in and follow along and understand that you'll be filling in kind of blanks, things that you don't understand over time. The other thing that's a little bit challenging about this course is that it is very self-directed. So again, Jeremy will present there's a Jupyter notebook that you'll need to get installed on a GPU machine. The lectures are basically walking through the notebook, and there's sometimes the lectures and what's in the notebook that you actually have are going to be a little bit different. But it's very easy to kind of shift enter and kind of run through the notebook without really kind of fully understanding what's happening. And what I think the conclusion that I came to, having done the course, the first course, is that one of the things that's uncomfortable or challenging about the course is that a lot of what you learn is by taking what you've learned in the notebook and replicating it against other data sets kind of on your own. And in the first few sessions, he'll tell you, specifically what to do and how to do it. So for example, you'll build a object detector against this cats and dogs data set in the provided notebook. And then, he'll say, go find another one on Kaggle, or there are a couple that he mentions, go try it against this one, go try it against that one. And that's the extent of your homework. There's no quizzes, there's no tests, there's nothing like that. And then as you go further, he doesn't really suggest anything in terms of follow-on work. You just kind of have to figure out what's interesting, find other materials about it, blog posts about it, and kind of explore it more deeply, find other data sets and try to apply what you've learned against other data sets, make tweaks to the notebooks and see what happens when you tweak the notebooks. It ends up being, kind of very self-directed. And so, between those two factors, the top-down and the self-directed nature of it, it can be, again, kind of this uncomfortable experience for much of the time. But at the end, you'll kind of look back and you realize that you know how to do these things that you didn't know how to do before. And it all kind of works out. And that's I think, the beauty and the magic of the course. So let me pull up. I had, when I did the last session of the course, the first week was kind of a week 0. Hold on 1 second. All right. So when I did the first go around of this study group, the first session was really just orienting people around the course and seeing what questions folks had. I've got some notes that I'm looking for. One of the big questions that came up for folks was what the compute requirements are.
Really?
You,
Because the back of her hair keeps getting shorter.
all right,
Oh my God, where's her hair?
There. Oh, got it. All right. And so I'm looking for my notes on that.
At the end of the course, will we have a notebook that we can run on our laptop or where we want, or is there some restriction to GPU?
So you basically can, all of the notebooks are in a GitHub repository. You can clone those wherever you want. What I ended up doing was there was the notebook that was distributed, either you cloned it via a GitHub repository or it was baked into some image that you end up using. What I ended up doing was cloning or copying the notebook for a given session and then making all my changes in that notebook. And you can kind of take those and run them wherever you want. But you will end up with a collection of notebooks. It's not a single notebook per se. Where is this? Well, while I'm looking for this, here it is. While I'm looking for my notes here, where are folks in terms of the, finding a place to run this? Does anyone have questions about that, or would it be helpful for me to run through what some of the options are and talk about that?
Yes, Sam, can you hear me?
I can.
Good. Yeah, I wasn't sure. Sorry about the audio issue there. I didn't realize exactly how this was going to work. I have spent the entire week trying to figure out how to set my computer up in the correct environment for following the course, because I tried Docker, and every environment that I downloaded successfully from there was the old course, and it's changed. So I'm setting it up outside of Docker now. I'm wondering if there's a good set of instructions on how to do that exactly so that it matches the course in terms of the right version of Python, etc.
There is a thread in the Slack channel. First of all, before that, if anyone is not signed up for the Meetup Slack channel, you should definitely do that. There's a Fast.ai channel on the Slack that's dedicated to folks that are working on this course. If you maybe signed up for the Meetup a long time ago and don't have, lost the Slack invite or something like that, just send me a chat message or an email, sam@TWiMLAI.com, and I will resend you that Slack invite. But there's a lot of good material on that Slack, and it's a good place for conversation. And if I can find it, I know you said not Docker, but Kai, who did the course the first time with us, put together a kind of a walkthrough on how to set it up with Docker.
I tried that, and I was able to download a couple of Docker images, and then every time after that it kept saying out of space, and I wasn't able to solve that. So I did see Kai's, but it was in the latter couple that I tried to download, and they all failed.
So for that, I tried on the GitHub page for Fast.ai in the README. There's a link to a Paperspace doc, and that's what I tried, and it worked very well. The setup was minimal. So basically, you get a pseudo access to an account on Paperspace, and you can SSH onto there. And at least for me, that worked quite well, following the instructions from the link on the GitHub README page. But
Yeah,
I know
I was trying to set it up natively, so I'd have it at home, and so I'd learn how, and that's just the way.
Oh, okay.
Like, that's the old bottom-up approach. I know I should have gone the Paperspace way, I think, in hindsight now, but I just thought, I found one set of instructions for setting up a computer with all the stuff except Jupyter that's needed for this. I think I just wondered if there was another set of instructions somewhere for setting it up natively on your computer rather than using Paperspace. I can go the Paperspace route if I have to.
If you haven't tried Kai's instructions for Docker, again, a lot of people the first go around use those and reported success, and Kai is very active on the Slack channel and would be more than happy to help out with that. I think other than that, if you look at like the Docker file for that, it's mostly just installing Anaconda and some other requirements, and then kind of cloning over the Git repository for the course.
Yeah, there is on a GitHub repo for Fast.ai. There is also instruction how to install it locally. So it's using Anaconda.
Yeah, there seemed to be some, and the confusion on my side from the old course to the new course, I think, the 2017, 2018, because one of them kept saying you needed Python 2.7, and Other ones were saying you needed Python 2 or 3.5.
Yeah, it's Python 3, yeah.
It's Python 3 now, I understand, and
That's
it's
right.
because it switched over to PyTorch instead of TensorFlow, I think.
Correct, yeah.
Yeah, that's okay. But,
yeah, but if you want to use an account, there is instructions from sorry, from Jeremy at his GitHub page, at the GitHub repo of the course, on how to do it. I've tried that on my computer, but I don't have GPU, so I've tried the CPU only setup and had some issues with that. But if you have GPU, I guess that should work.
So,
yeah,
so
okay.
just on that, Sam, would you recommend GPU or the models that we'll be running? Would we get away with CPU only, or does it make much of a difference if we don't use GPU? For the data sets.
Jeremy strongly recommends GPU. My experience is that I think going through the course, I spent so much time, like the vast majority of my time was spent like trying to understand what was happening in the notebooks, and much less on kind of running the training. So I mean, it depends. Like it depends on how you organize your time. If you can kind of run things on a CPU machine that you had overnight or something like that, and that won't get in the way of
Capture.
and that won't get in the way of your learning, then you know that might be a reasonable thing to try. You know, it's a machine you have, it's sitting on your desk. I think what GPU does is, you know, it allows you to kind of go through the course a lot more quickly, or it allows you to kind of go through the training a lot more quickly. And so if you're kind of interactively working through the notebooks, you know, you'll see the training happen so fast. But the training, you know, once you get past the first couple of lessons and you're training things from scratch as opposed to like fine tuning, the training takes so long that, you know, you're going to get up and go and do something else anyway. So if you can set it up so you're doing that overnight or, you know, between other work, I think a CPU could work, but I haven't tried it. I mean, it's you know, a small multiple of the amount of time that the GPU is going to take, you know, 5x, and you organize your time well, you could get away with it. Anyone have any other thoughts on that?
Well, I'm still trying to find the my email showing me what types that we had, what choices we had. Still trying to hunt that down.
Yeah, so the basic choices are run it on a machine that you have, CPU or GPU, or run it in the cloud somewhere. And in the cloud, there are a bunch of good choices. Paperspace was one that was recommended, and my experience with Paperspace, I tried to use that was my first choice. My experience was mixed. They, at the time, were running into a lot of resource issues. Basically, people were kind of slamming the service, and they didn't have GPUs. So you create a machine, or you'd create an instance on their gradient service. You try to, my experiences were mostly with creating a machine. You'd create a machine, you'd kind of do some work, and then you come back the next day and try to instantiate your machine. And they didn't have any machines of that type available, so you were kind of stuck.
How about TensorFlow?
What's that?
How about TensorFlow, the IBM product?
I didn't try any IBM products. I ended up doing most of my work on Google Cloud. So with Google Cloud, you basically, you can get a $300 credit when you first sign up as a trial, and you can't apply that to GPUs unless you put in a credit card. But once you put in a credit card, you can apply that $300 credit to GPUs, and I did everything on a Google Cloud instance. Kodzax in the group chat is talking about Kaggle kernels. That's a free offering. I don't know much about it.
Yeah, I think it's quite good. The Kaggle kernels, I just recently started using those, and for that course, I think it's quite good because mostly they use the Kaggle data sets anyway, Kaggle competitions. So you can very easily get the data, and in fact, there's someone who created all the lessons in kernels, so you can basically fork them. And you can run them with no credit card, with GPU, and they just work. So,
oh, wow.
I think that's good. So there are a couple of limitations though. So the session time is like 6 hours limit, which I think should be more than enough to run one lesson in one session. The other limitation is that the files that code is going to generate, like some temp stuff and some model information, all that information is going to be lost once the session ends. So that could be a limitation. So you have to rerun that again. There is a workaround to that. So you could get the data from the session to your local computer with the file link kind of command, and then upload that to a kernel drive. So you have 20 gigabytes of space there that you can store data. So there are some limitations, but yeah, it works. So that could be easy start because you don't have to wait for approval of GPU. You can just fork a kernel and just run. Yeah.
Is there a write-up of the kind of this workaround for saving your?
Yeah. So I just did that yesterday using FileLink, and then I uploaded that data. I can write it up. Yeah. It's just 2 steps basically. Yeah.
I think in one of the links that was shared, there's something about that as well, about how to get around that.
Is it? Okay. Maybe
I believe in one of the 2 though. Yeah.
Maybe it's a better way, because that seems quite silly, because like yesterday I had to download like 1 gigabyte of data to my local drive and then upload it again. So that's kind of silly. So I hope there's a better way of doing that.
So Xander, were you referring to one of the links that was shared in the chat here?
Yeah, there were a couple about using Kaggle kernels, and I had initially when I did the first couple weeks of the course just on my own, and when I was going through it, I was using Google's Collaboratory, which is a free sort of hosted Jupyter notebook with a free GPU. The problem there is that every time the session goes away, so I would go back the next day and you have to reinstall everything, which took forever. But Kaggle has all the dependencies built in, and the data sets are just there, so you don't have to download them. So it's really, especially if you have limited time, it really just like lets you kind of come and go really easily. And one of those links that Kojak shared, I believe, I don't know that there isn't necessarily a workaround for the needing to download and upload, but at least it explains the process if people want to know how that works.
Okay.
Yeah.
So it sounds like unless you have a specific reason to do something else, the kind of fastest, cheapest way to get going would be to use Kaggle kernels at this point and follow along with some of these articles to understand what the limitations are and how to work around those limitations.
So I'm just searching the Kaggle kernels now, and so for example, for lesson 1, there are multiple kernels for that. Are you using the one with the highest number of upvotes, or is there a particular user we should use for that, or is any of them?
Yeah, the one that the guy that posted that on Medium, maybe he was even first. It's called William. What's his name? William Horton, I believe. And there's a link in a chat.
Okay.
And there's a link in the chat.
There's also, I mean, what that is just a service to let you create your own notebooks. I mean, and if you're following the course and sort of following the methodology of taking what he does and then replicating it with a different data set. You don't necessarily need to fork an existing one. I mean, you can use those as a basis because they have all the imports and some of the setup.
Yeah, yeah, that's right. The advantage of using the kernels from William is that they just work, because there are a couple of things that needs to be changed in a code because of the structure of the where the data is stored on the kernels. So basically, they just work out of the box. You can just shift enter the whole thing, and it just works. And if you just upload the notebook to, like, if you just clone the from Fast.ai repo and upload it, you have to tweak that yourself. So if you're just starting and want something that works, I think it's quite a good solution, I have to say.
He's actually the top number of votes as well. He's the first result.
Yeah, that's right.
That's great. Thanks.
Any other thoughts or questions on getting set up and access to machines, GPU, that kind of thing?
Well, one thing that might be related, what is this meeting on the 19th at 5? Is that the class or?
No. Okay, so that's probably worth we've got a lot of stuff going on now. So under the banner of the TWiML Meetup, we've got several different programs. I host a monthly meetup that is that occurs early evenings, North America times, and the focus there is on reviewing academic research papers. So the general structure of the session is, we'll spend 15 minutes or so just kind of checking in, talking about what's been going on in the industry, interesting things that people have come across, and then 45 minutes on a presentation about a research paper. I've been doing that for about a year. We just launched a second session of that that is basically the same general structure, but better time for folks that are in Europe, Middle East, and Africa. It happens their evenings. So the session that you mentioned on the 19th, that is one that I'm hosting. It is a meetup. David Clement, who actually went through the first round of our Fast.ai study group, he's going to be presenting a paper on Deep Mimic, which is a reinforcement learning paper. So those are the two meetup programs that we have. And then there's this, the Fast.ai Part 1 study group. This is going to be happening, again, I need to confirm with Sebastian, but either, I believe weekly, potentially every other week. And then there's also some conversation about starting up a section of the Fast.ai machine learning course, which is a course that is about classical machine learning as opposed to deep learning.
Yeah, if you're interested of hosting that, we could do it together. I'm also interested in that, so let me know. Yeah, they mainly do random forests and neural nets for kind of called structured tabular data. Yeah.
Yeah, and there is. Were you one of the couple of people who was thinking about doing that one?
That's right. Yeah, there were I think 3 more people interested. So I think, yeah, I would be interested to do that. But it would be nice to have like more hosts to kind of share the workload and stuff, because it could be a lot of work, as you know, Sam, as well.
Yeah. Stay posted on the Fast.ai channel or on the meetup in general for more on that. What was I going to say? The courses, Jeremy often says that the two complement each other well. So if you're interested in potentially doing both, they're it sounds like almost designed to be run in parallel. And that you're learning things about kind of classical or basic machine learning, and then doing similar things on the deep learning side. I've not done the machine learning course, but just looking at the overview of it, it seems pretty solid.
Yeah, you just need twice as much time though. So because you need like 20 hours a week because it's like 10 hours per course. That's the only thing.
Yeah, but fortunately for me, I'm retired.
Right. You can start part 2 at the same time. So yeah.
Yeah, I guess one other, I kind of alluded to this earlier, but one other note, just for kind of setting expectations and encouragement. My experience personally was that going through this course, the first 3 lessons were like, we kind of breezed through them. They were really easy, very clear direction on what to do. And the 4th one was when it started to get a lot more challenging. And so just be prepared for that. And, don't be discouraged. Just kind of, do what you can do to stay up. We've got more time built into this session. Just do what you can do to keep up and try to do something, every week, every couple of days to stay on top of it. And again, you'll come out of it and you'll have learned quite a bit. The overview of the course, the first lesson is, we'll talk a little bit about kind of getting started and machines and some of the stuff that we talked about here. The second lesson is focused on kind of basic deep learning algorithms and applied to computer vision and object detection. The third goes into a lot more detail on convolutional neural nets. The fourth goes deeper into different training techniques and gradient descent and some of that detail. The fifth lesson switches gears a little bit and starts talking about natural language processing and the concept of embeddings, word embeddings in particular. And that maybe it's not in my notes from before I did the course, but that may be where we start talking about this concept of entity embeddings, which are applying deep learning to categorical data, which is a really interesting part of the course. And then in 5 and 6, we're talking about recurrent neural nets. And then in lesson 7, we come back and go into a lot more detail on CNNs again. And the expectation is that you should plan to spend around 10 hours a week. Again, it'll vary depending on the lesson, but also how much work you do outside of the, beyond just kind of running through the video and the notebooks.
I have a question.
Yep.
Would it be helpful to look at some non-course documentation on PyTorch, whatever is available there? Or will I learn everything I need to know about PyTorch explicitly in the course?
Yeah, so that is a good question. You don't actually see PyTorch until the very end of the course, because the course is built around this PyTorch wrapper that is the Fast.ai library. And so most of what you're doing is working with this Fast.ai library until lesson like 6 or 7. What would be helpful if you want to do something in parallel is NumPy. It's very helpful, particularly at the end of the course, but even in the beginning. A lot of the time that you're spending, if you're trying a new data set, is going to be figuring out how to get it into the format that the Fast.ai library expects, and NumPy can be really helpful with that. I just came across a I'll try to find it and post it. A couple of days ago, a kind of a crash course on NumPy that was part of some other course. What was that? Actually, it's the Stanford CS231N course, the CNN, the deep learning course at Stanford that I think Andre Karpathy runs. Someone produced a NumPy like crash course or mini course that that is supposed to be really good. So somebody also said that on the chat. Yeah, so if someone can find that and post a link to it, that's a really helpful introduction to NumPy, which becomes really helpful throughout the course.
And one other question then, with your experience so far, at the end of this session, the course one, would I be, if I wanted to go on and use some of what I've learned with my own images or documents or whatever, would I be using the Fast.ai library, or down one level using PyTorch or something else?
So what the Fast.ai library does, the other thing that's really interesting about this course is that Fast.ai, so Jeremy and Rachel and the Fast.ai community has done a lot of really interesting work to identify and incorporate kind of cutting edge training libraries and algorithms, not libraries, but algorithms. So in this course, you'll learn about things like cyclical learning rate, using cyclical learning rates, and just all different kinds of ways to manipulate your learning rate and other parameters of training to give you better training results faster. And all of those things are kind of baked into this library. So to the extent you can use the library, I think it's their intention that people use the library beyond the course. It is kind of, I don't know. I joked about it last time, like, in one of the sessions last time, that it looks like it was written by a Perl developer. And then someone later told me that, yeah, actually Jeremy is a Perl committer. Like the function names are really short and the parameter names are really short. And it's just, it's not the most user-friendly interface from my opinion.
Yeah, they've, on that, they've posted like the reason why they did it. So apparently there is someone that created that logic. So all the functions that you use like daily, like multiple times a day, those are very short because you use them a lot and then you remember. And those that you use less often, they are like should be more self-explanatory. So I guess that's why they do it. But I understand that it's not. If you just start if you don't use it quite often, it could be. It's also was for me as well. Yeah.
So I think Jeremy would say yes. It's an open source library. You're welcome to use it, and it'll probably save you a lot of time. And then, by the time you finish the course, you'll understand a lot of what the library is doing. The library, you can just read that code. It is basically just doing PyTorch code under the covers. And so if you wanted to move away from the library, you're welcome to do that. They are, in fact, in the process of building a new version of the library now, kind of rewriting it totally from scratch to support, I think, a different way of organizing the course. But there's more conversation about that on the Slack, and there are some posts in the Fast.ai forums on that as well. That's probably worth calling out. Our Slack channel can be a great resource because there are going to be, some 30 some odd people running through this course at the same time, and then the same amount of people who have already done it. But the Fast.ai forums are also very, very helpful, and a lot of what you'll run into, people have already struggled with there. Each of the lessons in the course, by the way, has a wiki page. And if you go to that wiki page, you'll find several of the people who did the course previously wrote up like their own step-by-step blog posts, you know, kind of breaking down everything that he does in the notebooks or in the lectures. And those are usually really good and really helpful. So make sure to check out those wiki pages too.
I found, at least for the setup stuff, some of the wiki pages were kind of out of date, which was part of the confusion I ran into, I think. Maybe that's less true for the content of the course, per se.
You know, what I remember from some of the, maybe not the wiki. So, okay, first of all, there are two versions of the wiki pages. There are the wiki pages from the original version of the course, which use TensorFlow, and then there are wiki pages from the more recent versions, which use PyTorch. You got to make sure you have those. But then what I found most valuable, the wiki pages for me were just pointers to other interesting resources like, you know, papers or blog posts that students have written, or, you know, some of these kind of walkthroughs. And, you know, those are, I don't think those will change that much if you're on the right versions.
Right, okay.
Yeah, the wiki for the current version of the course is not to the same level as the wiki for the old version of the course was. That's true. It's more of like a pointers to things, and the old one was like quite comprehensive.
Oh, was it really?
Yeah, it was quite cool. It's a shame they didn't update that, because that was really had a lot of information.
Any other thoughts or questions before we wrap up for today?
I have one other question. Are there, going through Andrew Ng's deep learning specialization, he had pointers to literature, to some papers now and then about the first GRU paper or something like that. Is there anything like that in this course, or does that kind of violate the top-down approach?
No, I think they point to papers. For example, he'll reference papers quite frequently in the lectures, particularly the early ones, the stuff that I mentioned, like the cyclical learning rate. I think that was one where, you know, he'll introduce these papers and say that, you know, they were largely undiscovered. He had no idea why no one, you know, was using this, but they found it and they had great results. And, you know, there'll be a link to the paper on that wiki page. So there are a few. It's not particularly dense with those kind of references, but there are a few.
All right, thanks.
I have a question. I want to follow up on the discussion on where can one run the code. So basically, consensus is that Google Colab is not a good environment, and Kaggle is better, right?
I would say what I heard was that, I haven't used Kaggle, what I heard was that Kaggle is better because it's integrated with the data sets which we use for the course, and because it's free. Colab, on the other hand, instead of 6 hours, is 12 hours. But every time you want to instantiate a resource on kind of a kernel in Colab, you have to go through this install process that's kind of slow. And then I found trying to get it integrated with, it's supposed to be easy to integrate with Google Drive, but like getting data in and out of Google Drive, I found to be kind of a pain. I guess that would be equally painful with Kaggle, so maybe that's not worth mentioning here, but I ended up playing with Colab and not liking it that much.
Also, I have another question. You mentioned that classes, the lectures actually, kind of half of the lecture is going over the previous class. So did you find that you wanted kind of every week to be dedicated to one one lecture you sort of want to do half of the next lecture, so you know the answers. So the kind of you do the exercises and then you check with the next maybe with the next lecture.
Yeah, I mean, that's a totally viable approach, and there's a distinct break in the middle of the next lecture where he says, okay, go, I'm going to go get a glass of water or whatever. They turn the camera off and back on. And I'm pretty sure that was pretty consistent through all of the lectures, that it was like the first half or so was the previous one, and then maybe not half, 40% or whatever, but I think that was pretty consistent across the lecture. So you could try to basically each of your study weeks would be, the last half of one video and the first half of another video. That would be a totally viable approach.
Yeah, the same is for the machine learning class as well. So it could save you as well some time and pain. So like I was struggling with some stuff I've learned on, say, lesson 2, and then on start of lesson 3, he explains, oh, sorry, by the way, you should have done that because that would save you like loads of time. I say, oh, thanks, yeah. So that will work. But on the other side, it's sometimes good to run through that pain, so then you remember those things, because if someone just tells you, you just forgets. I'm not sure what's better, actually.
Yeah. Does anyone know if the applications for the International Fellow for the 3rd version of the course have opened up? I'm not sure. I haven't seen that. I saw they are taking applications for a Diversity Fellow, I saw recently. And I think the International, I remember someone saying the International opens up after that. I'm kind of speculating. I don't remember exactly what I heard about that.
Yeah, just keep checking the Fast.ai page where they should announce this opportunity. So far, it's not there.
Cool. Well, it is the top of the hour, so we'll wrap things up. I think we covered anything. If you have any additional questions, jump on the Fast.ai channel in Slack. If you have problems connecting to Slack, you can email me, sam@TWiMLAI.com. If you are available on the 19th, Wednesday evening, the David session on Deep Mimic should be really interesting. If you've got an interest in reinforcement learning and some of the advanced applications of deep learning, and you're welcome to join us. All right, thanks everyone.
Thanks.
Yeah, thanks, Sam. It's great.
Thank you.